Upload your doubts on the app to get video solutions.
A heavy particle hanging from a string of length L is projected horizontally with the speed of root GL. Find the speed of the particle at the point where the tension in the string is equals to the weight of the particle, right? So this is the scenario. In this scenario, we have a particle over here, okay, and this is having a horizontal speed of root GL, right? And let's say it goes somewhere here at which the desired condition is meeting. What is the desired condition? The tension in the string is equal to the weight of the particle, right? So where is our tension in the string? Our tension in the string is this side, right? And weight is here, but mathematically they both are equal, right? So let's apply the condition. Before that, let's understand what is happening here. What are the different forces which are acting over here? So if the particle reaches over here, the tension obviously is upward, right? And weight is over here, right? One more force is acting here, okay? If we split mg, this will go in this side. That is what? Mg cos theta, right? Mg cos theta. And along with that, there is a centrifugal force, right? Centrifugal force is what? Mv square by L. Where what is V? V is the velocity of the particle and L is what? The length of the string, right? Depending on the length of the string, okay? Because it is assumed to be, it is a circular motion only, right? So, it is having a mv square by L. Clear it is? Okay, fine. So, let's start with our conditions which are applicable here. So, first of all, at that condition, we know that our T must be equals to mg, okay? T is equals to mg cos theta plus mv square by L. So, T is equals to our mg cos theta plus mv square by L, and let's call it as V2. Why we are calling it V2? V1 is the velocity at over this point, and V2 I am assuming the velocity at this point, okay? So, this is our V2 when it reaches over there. Okay. So, let's apply law of conservation of energy. So, from law of conservation of energy, what is the energy at this point? It's a pure kinetic energy, right? No potential energy at this point, mean position. So, our pure kinetic energy, we know that it is half mv1 square, and when it goes up, it will be the sum of potential plus kinetic at that point, mgh plus half m v2 square, right? Let me remind you once again, at this point, the mean position, there is only kinetic energy. When it goes up at that point, it acquires a height. Sir, where is the height? So, our height is this part. This is the extra height h, right? We will figure out how much it is this height, okay? We will see how the equations takes the form by using this height, okay? So, there is a height h. We will substitute this part, okay? And then we will simplify our in this part mgh. Clear? So, half mv square, the energy at the mean position must be equal to the total energy at this point, which is the sum of potential plus kinetic energy, where v1 is the velocity at this point and v2 is the velocity over that point. Let's substitute the values over here. So, substituting the values, half m, what is v1? Root gl whole square must be equals to mgh plus half m v2 square, right? Okay, let's see what is the value of h. Okay. How do we find, sir, h? Okay, so we know, now understand very carefully, we know that this part of the string has a length L, correct? So, that is L here. Okay, this is L, and this length is also L up till here, because this is the same string, right? So, that is also L. Let me draw it a little here. Okay. So, here, let's see. Okay. Okay. So, this is our L. So if these are L and L, let's make a small triangle over here to understand it much better. So we have a right angle triangle over here. Okay. So this is our L. This is our L. Oh wait, this is not L. This is L minus H. Correct? If that whole thing is L and this is the height H, then this side will be L minus H. And this is angle theta. Then what will be our cos theta? Sir, cos theta will be base upon hypotenuse, and base is nothing but L minus H upon L. Correct? So if this is our cos theta, L minus H upon L, let's cross multiply. L cos theta will be equals to L minus H. So H will be equals to L plus L cos theta. Very important result. H is L plus L cos theta. So we have to substitute this in our main equation. So let's see what will be the form our equation takes. So half m root gl. Let's remove the square. So it will be gl equals m g. What's our L? H. Sorry. H is L plus L cos theta. L plus L cos theta. Or I have done a small mistake. It's H L minus. Okay, it's minus. Minus. Why? Because I have to take it on the other side. L minus L cos theta. Right? Plus half m v2 square. Correct? So let's rewrite this whole equation on the new page. Okay, and simplify it. So let me just rewrite this over here. Okay, from the beginning. So our equation is half m g l, okay, minus m g l minus L cos theta, and this was equals to half m v2 square, right? Okay. So let's expand it. It is half m g l, okay, minus m g l plus mgl cos theta. When you remove it, this will be equals to how much? Half m v2 square. Correct? Now let's subtract half mgl minus mgl. So that is how much? That will be our minus mgl by 2, right? So let me write here mgl cos theta, and I am writing this negative sign here. Minus mgl, half mgl we left with. Half mgl minus 1 is half minus half mgl, and that is equals to half m v2 square, right? Correct? Okay, let's move ahead. So now here, if you multiply the whole equation with 2, this will be 2 m gl cos theta minus mgl is equals to m v2 square. Correct? I hope this is clear. Okay. Now condition. Now this is very important here. But let's read the question once again to understand our condition. What is our condition? Find the speed of the particle at that point where the tension in the string is equal to the weight of the particle. So very important condition. What is the condition? Tension is equal to the weight of the particle. So let's write here. Given. What is given? Tension is equals to weight of the particle, T equals to mg. So let's substitute. Okay, so to substitute here, what we left with here is one second. So let's divide the whole equation with L first. So let me we will substitute this in a minute. So tension T is equals to mg. Let's first divide the whole equation with L, the red one. So this will take mg. Tension is here mg, and tension, wait a minute, this T is equals to mg. So 2 mg cos theta, correct, minus, one second, 2 mg cos theta minus mg is equals to m v2 square upon how much? Upon correct? Tension, okay? This will be the condition. So this, 1 second, I have done this condition is mv2, and 1 second, I have to substitute this in one more equation to get this tension. Okay, I have to substitute over there also. Okay, look at the first equation. In the first equation also we have to put T equal to mg. So when you put in the first equation T equal to mg, from this one, let's call it as first equation, equation number 1, we will get one more equation and then we will compare to get it. Okay, so here this is the one equation. Okay, 1 second, so let me remove this and put it in the equation 1. So from equation 1, if we substitute in equation 1 T equal to mg, our equation 1 will take the form mg. Okay, let's see the first equation. It is mg equal to mg cos theta. T I am putting as mg. So it is mg equal to mg cos theta plus mg equals to mg cos theta plus mv2 square by L. Correct? So let's take this mg cos theta on the other side. It will be mg minus mg cos theta. That will be equals to mv2 square by L. Correct? Okay. And mv2 square by L will be how much? Look at the red equation. Let's recall the equation number 2. From this equation number 2, if we divide the whole equation with L, okay, we will get mv2 square by L, right? So let's substitute on the right hand side here. Okay. So substituting this over here. So let's see what we get here. So mg minus mg cos theta, that must be equal to, putting here mv2 here, mv2 square by L, we will left with 2 mg cos theta minus mg. Correct? Let's take this mg on the left hand side, it will become 2 mg, and take that mg cos theta on the right hand side, it will be 3 mg. Okay, 3 mg cos theta. And mg cancels with mg and you left with 2 by 3 as cos theta. Correct? So if cos theta is 2 by 3, the angle is 2 by 3 at which you are getting this velocity. So let's find the v2 value. So if cos theta is 2 by 3, let's put it back to our main equation, the first equation, and that will be how much? That will be equals to, putting here theta as cos theta as 2 by 3, we left with mv2 square is equals to, equation number 2, let's put it here. In equation number 2, the red one, it will be how much? It will be 2 mgl cos theta is 2 by 3 minus mgl. Correct? And that will give us over here, let's divide the equation with m, the whole equation with m. So we left with v2 square will be equals to 4 by 3 gl minus gl, and that is how much? Gl by 3, and that gives us our velocity as v2 as root under gl by 3. Done.
Watch the complete playlist on the app Pions. Download the app now.